Hello everyone, welcome back to MGF1106. So in this video, I will continue with concept of probability. So far we already know the definition of probability. We know what a theoretical probability and empirical probability. Now, I want to use the permutation and combination concept to solve probability problem. Okay, because in this video we're not going to talk much about the theory, so we're going to jump into the example right away. Okay, so let's get started. Okay, probability. So I'm gonna just put over here probability part 2. Okay, part 2. Alright, so let's jump into the example right away. Okay, so I have the problem like this. Alright, example number 1. Okay, hitting the jackpot in Powerball. Okay, is not the only way to win monetary prize. For example, a minimum award of $5,000. $50,000 given to a player who is collecting matches for 4 out of 5 number draw from 69 white ball, and 1 number draw from 26 red ball. Find probability of win this consolation prize. Express this answer as a fraction. Okay, let's see how we do this. So we know that there are 69 white ball and 4 ball will be picked from 69 white ball. So if we do a quick summary here, so we're gonna have 4 ball, 4 white ball, and all of them from 69. So total we have 69. And we want to pick 1 red ball, and it's come from 26 red. And if you really see that they don't care, it doesn't care about the order, which one out of 4 white ball over here, which white ball go first, which one go second. They don't care about that. So it means right over here it's gonna be related to combination concept. But now we want to find the probability and probability of picking 5 ball over here. Okay, so first of all we need to know we need to find the sample space. We need to find the sample space, then we need to find the event space. Okay, so how are we going to find the sample space? Okay, we have 4 white ball from 69. That is no order needed, so we can go ahead and use combination concept over here. C49 69, I'm sorry, 69 4. So we just go ahead and put it into the calculator, or you use the formula. So we have 69 factorial, 69 minus 4 factorial, and over 4 factorial. And if you put it into the calculator, you're gonna end up with let's say 69 4. So you're gonna end up with 86,401 option. So there are 86,000 864,000. Sorry, 864,501 option to pick 4 out of 4 white ball out of 69 white ball. And the last one we have a C26 one. C26 one is just 26. 25, so just 26. Okay. So we have 26 options to pick red ball. Okay. But the winning number, the winning match contain 4 white ball and 1 red ball. Okay, that is the group of ball we want. So think about it. Right over here we have to use the counting principle concept right here. So this is the place for white ball, and this is a place for red ball. And over here we have 86,864,501 option for the Y. Then we have only 26 options for the red. Then if you go ahead and multiply them up, what are you gonna end up with? So you're gonna have 22,477,000. Okay. 22 and 26. Okay. So there are 22,477,026 options to pick 5 ball like that. Okay. So this one is the sample space cardinality of the sample space set right there. Okay. Hopefully I don't get anything wrong over here, because this is very easy to get mistake. So I can do the math again. The logic should be good, but I want to do the math again to make sure that everything is correct. Divided by 65. Okay, divide by 24. Alright, so look like it's good now. Alright, so this is a sample space. Okay, now we wanna pick only one collection of ball, which is four white ball and 1 red ball. Out of this, so the probability, so the event, the cardinality of the events will be only 1, right? So the probability of the winning the jackpot, because there's only 1 number for the jackpot. So the probability in this case will be 1 over 22,477,000 and 26. All right, so you see that how small it is, right? You put it into the calculator. This is like 0.00000. This is very small. If you go ahead and convert it, this gives you 4.48 times 10 to the negative 8. So the probability of winning a jackpot, winning lottery, is very, very small. Okay, I don't know so far who won the lottery. I don't know, but I have to say that in my opinion, actually I don't trust them. I don't ever think that anyone has really won a lottery. Or maybe they win a lottery and they try to launder the money. I don't know, but probability of winning a lottery. So this is mean that you have 0, 0, 0, 0, 0, 0. So this is negative. You mean there are 8 decimal place before the next decimal to get 4.48, 6, 7, like that. All right, see how small it is. This number. This one. Yep, that's very small. Yeah, super small. So it could be like if you multiply by percent, it could give you like 0.000000448%. See, no way you're gonna win lottery. Okay, no way, unless you get some help from God, or maybe some help from the devil. I don't know, but no way you're gonna win the lottery. If you maybe you spend like 22 million, I mean more than that, okay, to win the lottery. If not, try to win it. If not, if you just spend like $100 or maybe like $50 or maybe $1 to get the jackpot, no way. Okay. All right. All right. Example number 2. Okay. All right. How about this one? A club consists 6 Democrat and 4 Republican. 3 members select at random. So it's random, but with no order over here. You see that? To attend the conference. So we want a group of 6 Democrat and 4 Republican. Okay. And we want to find a probability of 3 Democrat. Okay. So we want 3 Democrat. Okay. So 3 Democrat only out of 6. Probability. Okay. So let's see how we do this. Find probability that select a group. So we want a group of 3 Democrat only. So first of all, we need to find the sample space. Now, so there are 6 Democrat and 4 Republican. How are we gonna find a sample space around here, guys? So we want to do because there's no order, so we're going to do 3 Democrat or 6 Democrat combination. Yeah. So 3 out of 6. It must be the event space. But before we find the event space, we have to find the event. We need to find the sample space. So the sample space over here should be the 3 out of 6 and 4. So it will be C 10 4. Okay. So you're gonna have to put it into the calculator, or you use the formula. So let's see what you get. Okay, so you have 210 210 option to pick three. To pick three member. Because we want to pick three member. Okay. So this is the sample space. Now we want to find all three member Democrats. So you can do 6-3. Oh, 10-4. 10-3, not 10-4. I don't know why. I don't know why I do this. So this one. So they go with 3. 3. So it's not 210. Let's do it again. So you're gonna have 120. Okay. Okay. Then we're gonna do this 6 minus 3 factorial. 3 factorial. So 6 probability. So it'll be 20. So the probability in this case, this will be the event space, event set, sample space, and event set right here. So you're gonna have 20 over 120. So you have 1/6. All right, probability is 1/6. Okay. Now for part B, we want 2 Democrats and 1 Republican. So 2 Democrats. So we do C62. 6 factorial. 6 minus 2 factorial. 2 factorial. So you can have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And 1 times 2. So you cancel 1, 2, 3, 4. 1, 2, 3, 4. So you have 15. So 15 15 way to pick 2 Democrat, 1 Republican. So you're gonna do C for 1, just 4. But we want to find a group of 2 Democrat and 1 Republican. Okay, 2 Democrat and 1 Republican. 1 Republican. So 2 Democrat and 2 Democrat, 2 Democrat and 1 Republican. So we have 15 methods to pick 2 Democrat, and you have 4 options to pick 1 Republican. So 15 possible way to pick 2 Democrat, and 4 possible ways to pick 1 Republican. So it means what? It means that you will have 4 times 15, which is 16 possible way to pick 2 Democrat and 1 Republican. Okay. So this one will give you the sample space. Okay. So actually this is a sample space right here. Now we have a 1 group only. So the probability in this case will be So the probability in this case will be 60 over right over here 120. This is the sample space 120. So this again, this is not sample space. This is the cardinality of the event set right here. But we need to divide by the sample space, which is 120. So you're gonna end up with 1 over 2. Okay. Good. All right. All right. Again, this is not a sample space. The sample space right here. I'm sorry. We already calculate the sample space up here, right? This is the sample space. Okay. You see that we always have 120 at the end in the denominator. All right. Example number 3. You know what? I'm gonna go ahead and delete this. What's wrong with this? Okay. Okay. So example number 3. Okay. All right. I have simple 5 people line up randomly for the picture. What is the probability when they are in alphabetical order? Okay, see that? Order from left to right. Order from left to right. And 5 people line up randomly for the picture. Okay. So this is look like that we have the permutation, right? What probability they are alphabetical order from left to right. Okay. So let's see how we do this. Again, we're gonna find the sample space. So they put in order from left to right. So it means we're gonna do permutation. You can do counting principle over here too if you want to. We're gonna do permutation because permutation right over here will be what 5 people line up randomly for. What is the possible probability when they are in alphabetical order from left to right? So you're gonna have well 25 because 24. How many alphabetical letter from left to right? So you're gonna have 24 permutation 5. What is about alphabetical order from left to right? Yeah, we got a 24 alphabetical letter. Okay, so we have 24. Five. So this is give you 5100,480. So right now we can find probability because there's only 5 people line up for this only, so there's only one option. Probability with how many probability to get one group of 5 people. So this one group right here, so be 1 over 5100,480. So the answer is super small, guys. 1.96 10 to the negative 7. Okay. Yeah. Because the reason over here on the top, the events set we have over here, there's only one. We line up 5 people, you know, for one picture. Okay. So 5 people here. Just think about, you can have like A, B, C, D, F, then D, B, A, F, G. Oh, it could be different. It must be different number because it's not repeated. You know. So A, B, C, D, F, A, B, C, D, F, and G, H, I, J, K, and each of them is different. Okay. And it could be A, C, D, B, K. You know, you see that? Many different options over here. They have a lot. 5 million options. You know, many options right here. Okay, but we pick only one option. So it could be, again, if my explanation is for you to understand, and well, we have so many, because it could be A, B, C, D, A, B, C, D, E. Then it could be B, A, C, D, E. And it could be F, G, H, J, G, and no, it's not repeated. So I'm sorry. F, G, H, I, K. Okay, and so on. You list all of them, we give you that many. We'll give you that many. And you just pick one of them. One out of that many, so they give you probability. Okay? Alright. Example number 3. Okay. Example number 4, I'm sorry. So we have draw 4 cards, one after the other for the deck. So this is one after the other, it's in order now. What is the chance is to draw X, 2 Jack, and then the King in that order? Okay. So we know that there are 52 cards in the card deck. Okay. And we want to draw X, 2 Jack, then the King, so totally 4. Again, we're gonna find a sample space for us. You want to pick 4 out of 52. Oh, this is in order. I'm sorry. So this cannot be. It cannot be combination. Must be permutation. Because they say X first, then 2 Jack, and then a King. So must be in order. Yeah. Okay. So this one we're gonna end up with like 52 factorial. 52 minus 4 factorial. You put it into the calculator. You're gonna end up with a pretty big number also. You're gonna have with the 6,497,400. Then now we need to find the cardinality for the event set. Okay, so let's see how we do this. So we want to draw an X, and an X here. H over here, H. Sorry. There are how many H in the card X? There are 4 of them, right? 4 of them, and we pick only one. So in order, so it will be 4 times 4p1. We have 2 Jack, so we have 4p2, and we have 4p1 also. 2 Jack, 2 H, 2 Jack, and then a King. And we're gonna go ahead and multiply each other. Okay. So so we have 1, 2, 1, 1, 2, 1. Yeah, so I don't. Yeah, I think that's good. I don't think that we need another because there's only 4 core right here. I don't know why this one not good. Okay. Yeah, this look like it's stop being broken right over here. Okay. So you go ahead and multiply them up, which is give you mm, 2 jack. Okay. So P for 1, I'm gonna go ahead and put everything to the calculator. 1 is 4, so this is give you 4. P for 2 will be 2 factorial. 4 factorial will be give you 12, and this is 4. 16 times 12, 192. Okay, option. Alright, so we can find the probability now. It's 192 over 6,497,400. There you go. Which is 6,497,400. So which is give you 2.955 times 10 to the negative 5. Again, this is not, it's not a big one either. Okay, it's not a big one. Probability is kind of very small probability here. Okay. Yeah. Well, I stopped a little bit over here to check because it looked like everything's good. Because I thought there's another one here, but it's not. Because over here we already include 2 jacks. So because at the beginning I count 1, 2, 3, 4. 4 card. It's because it's 4 card, and I thought that there's 4 position. But over here we already included. So 1, 2, 1, 2, 3, 4. Yeah, because 2 jack over here is already in order. Okay, so we don't need it. All right, example number 5. Okay. Okay. Let's see. Okay, so we have birthday problem right here. What's the probability in a class of 20 students? No student had the same birthday. So birthday, you know that we have 365 days. So I mean we have 365 birthday. And we have 27, and none of them had the same one. None of them have the same one. None of them have the same birthday. Meaning we have to find permutation. 365, 27, which is a pretty big number right over here, guys. Okay. Okay, so this one, which is give you the events set right here. Okay, pretty big number. I just go ahead and set up, but I'm not calculate. You can go ahead and calculate, but it's give you pretty big number. But now we need to find the sample space. The sample space over here. So there are 27 of them. 27 of them, and none of them has the same birthday. So let's go ahead and do this way. None of them have the same birthday. So the first student, let's say you have 27 students. First student, you have 365 options, right? Then the second student, we also have 365 option. Now we're talking about a sample space right now. Okay, I'm not talking about the permutation. And the requirement over here is no student has 7. So you can have 27, 365 option for the first student. Then you have almost 365 for the second student. And we have 365 option for the third student, and so on. 365 for the 27 student. So this one to give you the sample space. Okay. Okay. Then from here, so you mean is the sample space over here is 365 raised to the 27 power. Then from here I can go ahead and calculate the probability, which is this is none of them have the same birthday. And then so this is a permutation right over here, so this is makes sense. Divide by the total of the divide by the total of the birthday 27 student might have. Okay, include the case when both of them have the same birthday. Okay, this is sample space, right? This is sample space. So this over here go 365 raised to the 27. Okay, pretty big one. If you go ahead and put into the calculator, 365 math, probability, permutation, 27. You divide it by 365 raised to the 27. You're gonna end up with about 0.0373. So about, if you convert it to that percentage, 37.3% to get a class of 27 students, and none of them have the same birthday. 37.3%. Okay, good. Okay. I just want to look at this and look at the example of a file over here, because I'm just afraid that some of you may have the question, okay, why we have to do the sample space, calculate the sample space like this instead of this. Well, the answer is, look at this. This one we want to pick 4 cards, one after the other. So actually this is 4 cards, one after the other. They already have in order. So you gotta use the permutation over here. This one, no. I didn't say anything about the birthday is not supposed to be the same or not. Why do you want to have 2 students that have the same birthday? But that is in the event space. It's not in the sample space. The sample space is just the number of birthday that 27 students may have. And of course, in this case, you're gonna have some of them repeated. Okay. Okay, but now look at that. This is different, for example, because even the next sample space over here, they have to use the permutation, because this is one after the other. So they already have in order right here. Okay. Same thing for this case. Okay. Oh, over here is easy because this, yeah, this is already in order. In order for this one. Okay. Uh, I'm just afraid that in this kind of question, we might have something 365 factorial at the in the sample space, because 27, 365 factorial, because you have 27, so 365 factorial times 364 factorial until no, yeah, I don't think so. So I think this is good, because I'm just afraid over here we do 365 factorial for the samples, but it's not. Okay, so this is the sample space right here. So you see that when you apply the combination of permutation, when you find the probability, there's more step you have to think. Okay, uh, you have to think more. Okay, and in the next video we're gonna combine all the n and r. We would have a compound probability. This that could be a harder case. But and you see that when you even apply the permutation and combination, this is tough already. Okay, you have to think. Okay, and I don't think that's the textbook mentioned too much about this type of probability. You might have seen it, but if you get stuck, you just let me know. Okay. All right. So I'm gonna stop the video here, and I'll see you next time.